Okay, so we're going to continue to look at the factoring. We're dealing with the trinomials 2, where we have a coefficient other than 1. Okay, again, you always still look for the greatest common factor. So let's look at this one. We have 20s squared plus 21s minus 5. So do we have a GCF? Nope, can't say 5 because 5 will not go into 21. Okay, so no, we don't. So this is a trinomials 2, so we have to work with the 20 and the 5. So you can do the first one method, the trial and error one, where you find the combinations of 20 and find combinations of 5 and put them together that way to get the 21. You go that route. Or you can do the divide and slide. I think I'll probably do the divide and slide with this one. Divide and slide technique. So again, we want to multiply A times C. So you got 20 times negative 5 equals negative 100. Rewrite as a trinomials 1. And so that becomes s squared plus 21s and then minus 100. So now it's a trinomials 1, okay? Okay, factor. All right, so we have to now find, okay, let me put my T parentheses. So we had to deal with this negative 100. So that product is negative, so that means the signs will be different. S squared, we have S and S. And so we need to get a middle term of 21, positive 21, but we're going to be taking the difference because the product is negative. So let's look at 100. So we have 1 and 100. That's not going to do. Let's see, 2 goes in 150 times. The difference cannot give me 21. Okay, next, 4 and 25. Hot, we hit it. Okay, so we don't have to go any further because we've already hit it. So we got 4 and 25. So to get a positive 21, so negative 4 plus 25 gives me a positive 21. So we'll do negative 4 and plus 25. So now what do I have to do now with the slide and divide? So now I have to bring back A. So divide by A, simplify. So if I simplify, that gives me 1 over 5, correct? If I simplify, I can divide 5 by each one, so that's 5 over 4. I still have fractions, so therefore, you don't want to have fractions in your factoring. So the denominator slide to the front. Okay, so I have 5s minus 1, and then I have 4s plus 5. See that? That was much easier. Okay, so that gives you that. See, otherwise you would be, you can do it another way, I guess the trial and error way. Okay, but then you have to try one, foil it out, or the end of the outer. If that doesn't work, try another one and keep going until you get to this solution. Good. So that's why I like the divide and slide for that one. So let's look at, now see if we look at this one, okay, let me see, this is the one before that, okay. We have to do it a different way. Okay, so let's look at this one. This one here, we see these big numbers. So we have 15x squared minus 62x plus 63. Now, see, if we decided to use the slide and divide technique, we would be dealing with a very big number. Okay, 945. And we don't really want to deal with that. Okay, so we may want to do, because that's still like a trial and error kind of thing. So we see that we can't factor out GCF. Okay, let's just do the regular technique, trial and error. We know that the product is positive, so the signs will be the same. So we know since the sum is negative, they're going to be both negative. So we can go ahead and put the negatives in there. Now, the x squared will still split that up to x and x. Now we have to deal with the 15 and the 63. So find your, list your combinations of 15, list your combinations of 63. So for 15, we have 1 and 15 and 3 and 5. And for 63, what do we have? We have 1 and 63. 2 will not go into it, but 3 will go into it. What? You got 21. And then you have, we'll do what? 7 and 9. Okay, nothing else before that. I think we're good with that. Okay. Yep. Okay. So we have more combinations of 63 than we do of the 15. So the question is now, whenever we do this here, we're trying to get these to add up to a negative 62. So that's kind of a big number too. And we're adding this, so the signs are both negative. So it's going to add. So now what combination of the 15 do you want to try first? Okay. So do you want to do the 3 and 5? Okay, so let's just try that. So 3 and 5. Now, looking at the 1 and 63, we know we don't want to do that because that's way over 62. So not with the 3 and 5, okay? And let's look at the 3 and 21. With 3 and 21, okay, even if we put the 21 here, let's just say, if we put 21 here and we put 3 here, that's 15, and that's 63. So that's not going to work. All right, so okay, look at the 7 and the 9. All right, so this is why it's trial and error, because you're trying one and it doesn't work. So 7 and 9. So if we put, let's suppose we put 7 here and we put 9 here. And so we do the inner loop, that's negative 35x. And then the outer loop, that's a negative 27x. Ooh, we might have a jackpot. And so when we add these, we get the negative 62x. So it worked. So we started off with the right combination of 15 first and then went down the list. Okay, if you had started off with the 1 and 15 and then went down the list and saw that didn't work, then you had to go down, do it with the 3 and the 5. So we found it. Okay, and so if you had gone down the list with both and nothing worked, then we would say the polynomial is prime. Okay, this is called trial and error. So your factors are 3x minus 7 and 5x minus 9. Good. And so again, we wouldn't have, I don't think we would have wanted to do the slide and divide with 945 to find a combination to get the 62. We would have been still working on that. And then you run into some problems where you do the trial and error and then nothing works. Okay. Here, yeah. So if you try to do it the same way, you'll run into it that the combinations don't work. Right. So let's look at this and see if the combination will work for this one. I'm just looking at it briefly, and I can see that 49 is a perfect square, 9 is a perfect square, and normally I try to do, their perfect square combinations to see, get the middle term, but it doesn't always have to be that case. All right, so let's look at it. So we have 49 r squared plus 41 r plus 9. Okay, so again, since this will, this would be a big number, I may not want to do the slide and divide. So I would probably just do the trial and error. Everything's positive, so when we factor it, everything will be positive. R squared will split up to r and r. Then we got to find combinations 49 and 9. That's going to give me a middle term of 41. So 49, we have 1 and 49 and 7 and 7. Okay, and then with the 9, we have 1 and 9 and 3 and 3. Okay, and normally time when we have like these doubles, I always start with those first normally. All right, so for 49, let's try the 7R, 7R, okay? And if we do with the 9, the 3, and 3, we can see that that's not going to, we get 21R and 21R, so that gives me 42R. So that's not going to work. All right, so we know that 7 and 7 will not work with 3 and 3. Will 7 and 7 work with 1 and 9? So if we do, we can see that 9 is way over, and that is 63, so that doesn't work, okay? And then if we use 1 and 49, so we know that 7 and 7 doesn't work, okay? So even if we try the 1 and 49, see that right away, the middle term is 41. That's way over 40, over 41. So that's not going to work because we're going to be adding, not subtracting. So it doesn't work. So what is your conclusion? The conclusion is that the expression is prime, okay? So not all polynomials can be factored. Good. Okay, so that takes care of this homework set. Okay, now we'll get into the special ones, okay, in the next one.